Hi everybody, welcome back. Today we're going to solve exponential equations, and we've kind of already talked about a little bit of these properties, but today we're going to get into some of the more complicated equations. So up here we have all the steps that we're going to follow. We want to have a common base, first of all. So make sure you can change one or both sides. We're going to use the properties of exponents, so adding is going to turn to multiplying, turns into adding, multiply turns into adding, and dividing, subtracting rather, will turn into dividing. I don't want to say it backwards. And then, of course, this is our main property right here. As soon as the bases match, we're going to be able to say the exponents are equal. But, of course, you got to throw in the properties. So, number one, you can see the bases already match, so we can kind of ignore them and just say 2x minus 9 equals 7. Then just solve the problem. And because your answer is a power, we don't care if it's positive, negative, or 0. So exact same thing happens here. We don't really care what the base is as long as it matches. So now we have 4w minus 1 equals 5 minus 2w. You just ignore the bases and say the powers are equal. I'm going to add the 2w and add the 1. So 6w equals 6, so w equals 1. Now, as far as the properties go, we have the same base, which is good. So on this side, we are multiplying. So multiplying turns into adding. So c plus 1. Oops, sorry, that's a minus 1. I'm thinking adding. So c minus 1 plus, because of the multiplying, 3c plus 2, and then equals the other power over here, 7c plus 16. And we just solve the problem. So here we have 4c plus 1 equals 7c plus 16. Now side to side, I'm going to subtract the 4c, so this is a 3c. I'm going to subtract the 16. This other side is negative 15, and we get negative 5 equals the value of c. And again, the fact that that's negative doesn't really matter because they're powers, they're not logarithms. So one more time with this. Again, of course, we have adding on both sides because we have multiplying on both sides, so that'll turn into adding. So this is k squared plus k. Over here, then, we're going to add the 2k minus 9. This, of course, equals 4k plus 11. Those are the powers. Now, you have k squared and k, so you are going to have to set this equal to 0 because that's the only way to solve it when you have a power of 2 and a power of 1. So we're going to set it equal to 0. So we're going to subtract the 4k, and then we're going to subtract the 11. And now you can factor it. So we need two numbers. You multiply to get 20. So 5 and 4. 5 is negative, 4 is positive, so we get k equals 5 and negative 4. So honestly, that is the easier of the two versions. The second version is when you might have to do a little work first. So using step 1 now in the directions, you might have to make the bases match first. So if the bases don't already match, then just make that happen. So we can clearly change the 81 to 9 squared. So we're going to do that. So now we have 9 to the 4y minus 26 is equal to 9 squared. Now the same rule applies. The bases match, so those are gone. 4y minus 26 equals 2. So 4y, add the 26 over here, equals 28, and y is 7. Negative exponents make fractions. 64 is the same thing as 4 to the third. Now to bring this back up out of the basement, that makes this 4 to the negative third. And of course now we can finish writing the problem. That equals 4a squared minus 4. Now the bases match, so negative 3 is equal to a squared minus 4. We don't have to factor this because all we have is a squared. It's when you have the letter squared and the plain letter that you have to worry about factoring. Here we can just take the square root. You do get two answers, remember, plus or minus 1. For this one, the 32 is going to have to go to a 2. 32 is equal to 2 to the 5th power. So now we have 2 to the m minus 9 equals 32 is 2 to the 5th. Keep this in parentheses because we have to distribute this, m plus 3. So m minus 9, because these are gone, equals 5m, distributing that, plus 15. No factoring necessary here. I'm going to move the smaller letters. So negative 9 is equal to 4m plus 15. Subtract the 15. So we get negative 24 is equal to 4m. So m is equal to negative 6. Now these all have the same base, so we don't have to do anything to them except for the fraction. So as you know, the fraction is a negative exponent, so this is really going to be 12 to the negative 1. Now we have this power up there, 4x plus 3. This is times 12 to the x to the second power equals 12 to the 2x plus 13. So now that all the 12's matched, we can get rid of these. So I'm going to distribute the negative 1 also. So negative 4x minus 3. The times turns into plus. The equal stays equals. Now we have x squared and x. So I'm going to move all this over to here. And I'm also going to write this in a better order because this equals 0 now. So we have x squared minus 6x minus 16 equals 0. And now we can factor this. Multiply to get 16. So 8 times 2, negative 8 plus 2. So we get x equals 8 and negative 2. These are a tiny bit more complicated. You can see the numbers are larger. Use your calculator if you need to because you're not sure what's going on with these powers. 216, since these are always in 36, let's see if 216, 36 squared is not 216. So we can't use 216. We're going to have to think about a number different than this. This is really the number that I'm worried about right here because I don't really know that number too well. This is actually 6 to the third. That's just found by guessing and checking. Now I use 6 because I can write 36 as 6 squared, and this is a 2x. This is going to be 1 over 6 squared, and now I have this is equaling to 6 to the third. So this has to be switched to a negative power. So this is 6 to the 4x, I just multiplied that, times 6 to the negative second equals 6 to the third. So the algebra isn't going to be any more difficult. It's just you might have to do some more thinking to get the bases to match. So 4x minus 2 equals 3. 4x equals 5, because we're adding 2. And we get x equals 5/4. So this is even stranger. So the 512, we got to go with the smallest base, which is 8. So we're good because 64 is 8 squared. So that's going to work. 512 is actually 8 to the third. So we knew to use the 8 because that was there. You can't make the bases larger. You can only make them smaller. So I'm going to rewrite this. So this is now 8 to the third, but there's a y squared there. Yeah, I guess I didn't need parentheses, but I did anyway. This is going to be 1 over 8 squared, and that whole thing is to the 3y power. And this is, of course, 1 over 8. I'm going to have to change this one to the 5y squared. So those fractions become negative exponents. So this is 8 to the 3y squared. This is going to be 8 to the negative second, but then that whole thing is to the 3y. And this is also 8 to the negative first now, but this is to the 5y squared. So we're going to multiply our powers. So 3y squared, multiply power to a power, equals negative 6y plus, because that's a times, and then we have negative 5y squared. I'm going to add the 5y squared to the other side, and we get 8y squared equals negative 6y. Now because you have y squared and y, you have to factor this, so we got to move this over here. 8y squared plus 6y equals 0. This is just greatest common factor, but it's still factoring. So you still have to factor it. So they have a 2y in common, leaves you with 4y plus 3. So we get 2y equals 0, so therefore y equals 0. Setting the other factor equal to 0, you get negative 3 here, so we get y equals negative 3/4. So this one happens to have two answers. Having powers that are zeros are fine, so you don't have to worry about that. 0 power is a 1, and negative powers are also good, so we're good.